Okay, today we're going to start out with copying down some instructions on how to graph rational functions. So please pause the video at this time to copy these notes down. Hello and welcome to Chapter 2, Section 6, Rational Functions. Today we're going to find the domain, tell if the function is continuous, and find the vertical and horizontal asymptotes. Well, let's start out with the domain. The domain is going to be everything but 2, because that's what makes the denominator 0. So we go from negative infinity to 2, and that's a union with 2 to infinity. Okay, that shows us that there's a break in our function, so we know our function is not continuous. Okay, the next thing we need to do is find the vertical and the horizontal asymptotes. Well, we determined the vertical asymptote from what we got from the domain, and that's where 2 did not exist. So the vertical asymptote is going to be x equals 2. Okay, now we need to do the horizontal asymptote. Since it's low over high, that means it's going to be y equals 0. Okay, that's all you have to do to be able to find the asymptotes, determine whether the function is continuous, and finding the domain. Okay, let's look at another example. Finding the domain, telling whether it's continuous, and finding the vertical and horizontal asymptotes. Well, as we look at the denominator, we can see no matter what number we put in for x, it's always going to be a non-zero number. So that means, very simply, that my domain is going to be negative infinity to positive infinity. And since there's no breaks, we know it's continuous. And we also know that the vertical asymptote does not exist. There is none, because there is no break in the denominator of the function. So the only thing we need to look at is the horizontal asymptote. Since the degree of the two polynomials is equal, we use the leading coefficients of each polynomial, that ratio, and that is going to be our horizontal asymptote, which that's going to be y equals 3. Our next example, we're going to find zeros, or what we also call x-intercepts. Well, the first thing I need to do is put it into fractional form. I have an integer and a fraction, and I need everything to be in fractional form. So first thing I need to do is find a common denominator, and my common denominator is going to be x squared plus 2. Well, that means that I need to take my leading integer and multiply it times x squared plus 2. And my 5, I don't need anything to do with it, so I can just write the 5. Okay, I distribute the 2, and that gives me 2x squared plus 4 plus 5 all over x squared plus 2. Okay, I do some simplification, and I find out that 2x squared plus 9, 4 plus 5, over x squared plus 2 gives me my fractional form. Now, since the numerator is 2x squared plus 9, I need to set that equal to 0 to find my zeros. Okay, so if I subtract 9 from both sides, I get 2x squared equals negative 9. And I divide by 2, and x squared equals negative 9 halves. Well, we know if we're working with real numbers, which we are, a squared number is never going to be equal to a negative number. Therefore, there are no real zeros. Here's another example where we need to find all the zeros, and it's already in fractional form for us. So all we need to do is take the numerator, x squared minus 2x minus 8, and set that equal to 0. Well, all that means I need to do is to factor, and that factors as x minus 4, x plus 2. Which means my two zeros are x equals 4 and x equals negative 2. Okay, our next example, find the domain. Is the function continuous? Find all intercepts. Find vertical and horizontal asymptotes, and then sketch the graph. Okay, we have the domain. Well, we know we get the domain from the denominator. What makes it 0? And if I put in a positive 3, that's what makes it 0. So that's where my break in my domain is. So I've got negative infinity to 3, union 3 to infinity. Okay, there's my domain. And since it does break like that, we know it's not continuous. Okay. Now, our x-intercepts, well, that's when the numerator is equal to 0. Well, since 1 will never be equal to 0, there are none. There isn't an x-intercept. Okay. Next thing is the y-intercept. And our y-intercept is when the x is 0. What is y? Well, if we put in 0 for x, we get the x-intercept to be negative 1/3. And the last two things are the asymptotes. Our vertical asymptote. Well, our vertical asymptote is what breaks up the denominator, which in this case was 3. So that's x equals 3. Okay, to find the horizontal, we do the degrees, and it's low over high, so that means the horizontal asymptote is y equals 0. Okay, now we've got enough information to graph. And first off, let's do our asymptotes. Well, we know our vertical asymptote is at x equals 3. Okay, and we know our vertical asymptote is at x equals 3. Our horizontal asymptote is at